Question number 5 is going to ask you about the translation from one graph and its original vertex and shape to the graph of a new function that has a different vertex and a different shape. So let's first think about what we know about the first graph. They gave us x minus 1 squared, which means that in terms of the vertex, its x-coordinate must be positive 1. That comes from the h value, the number inside the parentheses with the opposite sign. Since there's nothing after the square, the y-coordinate of the vertex must be 0. Now, there are lots of different ways we can visualize this, but the easiest way is often to draw a graph. And to use 1, 0 is kind of like our starting point. Then, of course, we can consider where the graph ended up. You can tell that the graph did indeed end up with an a value of 4, which means that the graph did get narrower. By default, the first graph had an a value of 1. Some people consider that up 1 over 1. And if we switch to 4, which means now going up 4 over 1, that means we have a much taller, narrower graph. The word for that we use is vertically stretched. Stretched is another word for skinny. So we can tell that because there's now this value of 4, it's going to cause the graph to have stretched. Now the coordinates of the vertex are going to be -6, -3. -6 from inside the parentheses, or -3 from outside the parentheses. If I graph that point, -6, -3, we can tell visually where the start and the end of this graph was. That might help us figure out some of these details. If I started here and ended here, I must have gone to the left. Specifically, I went to the left 7 units. Since I started at 0 and ended at -3, we can tell we definitely went down 3 units. Now, in terms of the shape of the graph, the initial graph definitely faced upwards because there was nothing with the a value to indicate any otherwise. And since the a value of the second equation is still positive, nothing about the equation changed in terms of the way it's facing, which means, whoops, that should actually be a little skinnier there, that even though it changed shape and got skinnier, it still faces upwards. So for the most part, all you have to do is think about where the vertex is, where the vertex moves to, and whether the a value goes fatter or skinnier. Skinnier is what we call vertically stretched, and that's when you have an a value greater than 1. The fatter graphs are called vertically compressed, and that's when we have an a value that's less than 1, typically a fraction.